Hello, everyone, and welcome to today's webinar series brought to you by the Critical Materials Innovation Hub. My name is Lestra, and I will be your host. Today's topic focuses on the successful creation of soft infrastructure for residential e-waste collection in an unregulated state. This presentation is brought to us today by Dr. Ruby Nguyen from the Idaho National Laboratory. For today's webinar series, it is hosted by Colorado School of Mines, and we would love some suggestions on future webinars. You can include your suggestions in the exit survey at the end of the webinar, or you may email us at cmi@mines.edu. This is a public webinar and will be recorded and available in about a week's time, both at aimslab.gov/CMI and on our YouTube channel, Critical Materials Innovation Hub. If you have questions for Dr. Ruby Nguyen throughout her presentation, please feel free to add those to the Q&A box at any time during today's presentation. We will have time at the end of today's webinar for some questions. And now I'd like to introduce Dr. Ruby Nguyen. Dr. Nguyen is a leading expert in supply chain analysis at the Idaho National Laboratory, where she leads the Dynamic and Spatial Systems Analysis Group. And with that, I would like to pass it over to Ruby to share with us more about her e-waste project.
Yeah, thanks, Celeste. And it's my pleasure to be here and present about my work, which is outside of scope of CMI. So people get to know me more about different angle or aspect of my work. Today's presentation will be broken down into 4 sections. In the first part, I will talk about the challenge, the opportunity, as well as the research landscape in residential e-waste collection. Then I will move on to some of the project overviews and the activities we're working on for the project I'm leading. And then I will talk about achievements and some of the insights and conclude with some next steps. Everybody knows that residential e-waste collection is a big challenge, is a global challenge. So to the left, you can see the chart from the Global E-Waste Monitor 2024, and they use the data from 2022. The top bar here is just showing e-waste generated per capita. And so Europe stands at the top at generating about 17.6 kilogram per person. And then moving down the list, here we have Americas. That's the combination of North and South America. And that's why the per capita generation is about 14 kilograms. And as you can see, there is a relationship between the income of these countries or these continents and the amount of e-waste people generated. And looking at the bottom bar here is the amount of e-waste being collected for recycling. And then it's converted to the pink number here as the percentage of materials or e-waste being collected for recycling. So Europe has the highest collection and recycling rate at about 43%, whereas in Americas it's about 30%. Specifically for the US, we have 2 mandated sources. So back in 2018, the EPA, Environmental Protection Agency, conducted a research, and they estimated that that year the US generated about 2.7 million tons of consumer electric goods. And so they have a list of what those items are. And they estimated about 39% of those items were collected for recycling. The more recent data was from 2022, with an estimated of about 6.9, so close to 7 million tons per year for the US, and about 25% recycling rate. So this data came from the US Public Interest Research Group, as well as the E-Waste Collection and Research Association. Continuing with the challenge, in the US, we have only half of the states with e-waste regulations, and that leads to limited infrastructure, meaning the drop-off locations and the pickup facility. The cost for those for e-waste recycling is also something that people want to avoid. And For other people, it's a lack of awareness. They don't know what to do with the devices, where to bring it to. The hoarding behavior is another aspect, especially related to data security. A lot of people don't want to recycle electronics with personal information because they're not sure how the data will be sanitized before recycling. And as you can see, for the case of Idaho, is pretty much rural state. Um, and with the picture in the bottom, you can see that for most people, when they have a broken vehicle or a broken boat or anything, they're just gonna put those items in the back of their yard um, as a way to, save memories, but also a way to reduce costs. And so it's a much more challenging problem for an unregulated state like Idaho. So looking at the opportunity, we have New York is a regulated state, and of course, the activities of e-waste recycling collection there is much more mature. So this is an example from our partner. As you can see, this is one of their collection events where the yellow arrow starts is from the road turns into the parking lot. And so there are about 12 vehicles there, keep going up another dozen vehicles, and then they turn into 8 lanes in parallel. And say the event starts at 2 hours after the event starts, then they fill up one semi trailer here and then ship the materials off site. Just a couple more pictures of how they operate the um, 8 lane drop off events, as well as you can see how they stack up materials. In this picture is a stack of CRT monitors that they put in those semi trailers. Talking a little about the research landscape, of course, this has been studied globally and using surveys. And by global, I mean there has been studies in Vietnam and India, in Spain, Brazil, so various countries in the world. Some of the main theory that people use include the theory of planned behavior or behavioral reasoning theory, or more specifically, the norm activation model. So these models look at how the people's attitude, intention, beliefs, or motives influence their behaviors specifically to e-waste recycling. The norm activation model believes that individuals will act or will have um, when they see the negative consequence from their inactivity. So that's the personal norms. And some of the ways that researchers report on this is using the structural equation modeling as a statistical analysis method that look at multiple variable. They look at direct and indirect factors and connect with all these um, internal factors like attitude, intention, and beliefs. I just want to mention here two specific research or studies. One is by Sephora and his group and their group. This study was issued or published in 2012. So they surveyed about more than 2,000 U.S. households back in 2006, and they used the NAM model. And they called those as internal factors. They also looked at the social demographic factors and considered those as external factors. Some key findings from this studies said that the internal factors are the most important driving the e-waste recycling behavior. And then after those internal factors are the recycling convenience, the knowledge about the materials, especially about how harmful certain materials in e-waste are, as well as prior recycling experience. They also believe that gender and marital status have an impact on e-waste recycling. The next research I'd like to mention here is by Otto and others, published in 2018. So this is a German study. They surveyed more than 600 German households. What I liked about this paper was that they conducted a few trials to actually estimate, how much e-waste was being collected given different treatment of the experiments. So they did two field trials. The first one is based on the infrastructure. So in Germany, the recycling infrastructure is developed, and so the control is to just remind people that there is existing infrastructure and keep recycling your e-waste, right? So basically, not doing much other than reminder. And then the experiment include they provide some curbside collection during a certain amount of time, and they also put out more deposit containers so that people can drop off more e-waste. They also did the second field trials, which is based on collection events. And so they also have the control and the experiment. So the control is just to say, so they send a leaflet or similar materials and say, there's an e-waste event on this day at this location, just come. Whereas in the experiment, they have a material enticement, meaning when you drop off you and take the survey, you can have a coupon for a food or a drink item. Or the social enticement is no incentives for dropping off, except for the fact that it's the right thing to do. It's good for the environment. So what they found out was that the combination between collection events and the social enticement had the best outcome out of all of the experiments they conducted. And overall, the collection events did better than the infrastructure-based approach, right? Although infrastructure is more costly, whether you have to provide more curbside service or you have to provide more deposit containers. So moving on to my specific project, this project is really compare the strategies to increase residential e-waste collection for two different states. So our partner in New York is Sunnking. They are a medium-sized business. They've been in the business for over a decade, and they've done a lot of collection events. Our partner in Idaho is ECyclers of Idaho. It's a small business, just in the business for a few years, right? And so, very contrasting pictures here. This project was funded by the Vehicle Technologies Office, and it is a 3-year project. We've just completed the first year of the project. So there are three main goals. The first one is to raise awareness for the public and also the students at school. We will also want to create the soft infrastructure so that we can increase collection. And the office especially cares about batteries. And one important aspect is to understand who actually goes to these events and what describes them or what attracts them to these events. So the approach that we took is that we organize indoor and outdoor free public e-waste collection events. So we still continue to do this as we speak. We collect basic information at check-in. So with the check-in information includes um, if the participants drop off e-waste for their households or for their neighbors or for their organization, and what are some of the items that they drop off, how they learned about our events, their zip code, and have they been to any of our events before. So we're just trying to measure very basic information, and this is different from the in-depth surveys toward the end. Um, and so for the surveys, we really dive into the individual and households characteristics. We also want to see how familiar people are with general recycling, and then the e-waste recycling, right? And we have to kind of distinguish the two parts because, again, Idaho is an unregulated state and we have a lot of land. And so we just want to see the even the general recycling practice, whether people are familiar with that. Um, and then we ask people to evaluate the convenience of different e-waste recycling methods, as well as tell us how they receive information about recycling in general, as well as e-waste recycling. So here are some pictures of how we organized the indoor events at the Idaho Falls Public Library. So we started this series back in February. Um, and the way we set it up, we have check-in first, and then people go in and then drop off their e-waste in the relevant bins. We have handouts, for example, the postcards for upcoming events, and then people, if they agree to a voluntary survey, they take once they complete, they will get some sweat item. And you can see because it's in an indoor space, so we limit the item that we can accept. So most of the materials here are phones, tablets, laptops, and in this picture, the bottom right, you can see some desktops, some printers, and even the vacuum cleaner. For the outdoor setup, we partner with Ammon City Hall. So the steps are somewhat different because we utilize the parking lot of the city hall. So we start with greeting people and hand out the information for upcoming events, and then we check them in, and then we let them drop off the materials, and if they want to stay to do the survey, they can before they exit. So far we held 4 indoor events and 5 outdoor events in Idaho. We got more than 700 drop-offs, and the survey participation rate is pretty high. So for social studies, 30% is a pretty good rate, and we got 55% participation rate. We collected more than 42,000 pounds of e-waste, and we also gained the partnership with local organizations, as I mentioned, the library and the city hall, as well as we have support from volunteers, including INL retirees and retirees in the community. Just a quick overview of what e-waste we've collected. Um, so you can see here, 2/3 of what we collected are e-waste without batteries. And then 25% of what we've collected are e-waste with battery and with data, and then the rest is battery without data, is about 8%. So as we collected data on the zip code, so we were able to map. So to the left is a map of people who went to the event through the check-in process. Um, so the 2 red dots in the center are the 2 event locations. And then if you see all the concentric rings here, they are 10 miles away from those event locations. And so you can also see here to the left, Arco and Mackey are about 70 to 60 to 70 miles away from the collection events, but people still drop off e-waste. So that's a very nice thing. We looked more closely at the survey participants. And so with the survey participants, it's a much smaller population compared to the total check-ins. Um, and so for the survey participants, we saved the census tracts, which represents their neighborhood instead of the zip code corresponding to how USPS um, deliver their um, packages. And so the the census tracts try to each census tract has the same amount of population. And so for a rural state like Idaho, people tend to spread out. And so the area of the same census tract is sometimes larger than a zip code area. But anyways, when you look at how far people are willing to travel and also stay to take the surveys, so people live within the 40 miles radius, we're happy to take our surveys. Moving on to some insights from the survey. I'm not going to present all the results today, but just some of the key things so that you have a sneak peek into the recycling populations in Idaho. So, in terms of the age of the participants, um, we can easily see that a very small fraction is in the age group of 18 to 24. It's understandable in the sense that, at these ages, people just, graduated from high school or graduated from college, and they've been moving quite a bit and don't really accumulate a lot of e-waste. And then for other age group, we see a more even distribution, and the more of people are in the 40 to 54 age group. I think what's also important is to capture the older population. So you can see here it's 65 to 74 is 18%, and 75 and older are 10% of the population, right? Talking about the total annual household income. So this is um, so for the most part, the area surrounding the lab is influenced by the lab quite a bit, and so um, this is unique to where we are organizing events, and we expect that this will change as we expand the the service area. And so right now you can see with the population that participated in our survey so far, a very small fraction. So 18% has the total household income of less than 50,000. Um, and then, the 100,000 and more is more than half of the um, survey participants. When we ask people about what are the barriers to general recycling, so this is we also call this commingle recycling. So recycling of cardboard, papers, aluminum can, certain types of plastic, and so on. And the and so in this question, participants can choose multiple answers as they are applicable to the situation. So cost is the number one barrier. So about 27% of people chose cost. The next aspect is limited items. And so especially related to plastic in our area, only plastic number one and number two are collected. And so for a lot of people, if they have more items they thought could be recycled, but is limited by what the service can offer, and so that's a barrier to recycling as well. About 20% of the people didn't know that there is recycling services in the area. So that something has to do with raising awareness about what is available. Only about 12% say that there's no real barrier to recycling, and the rest are like the service area does not, cover their household. Again, being in the rural area and where people spread out more, so that's more challenging. Some people are not aware of the general recycling basically because they are a tenant, and so that's the landlord responsibility. And time and effort is considered the lowest barrier here. We also asked them knowledge about materials. So we asked, what do you think? What materials are in a laptop? And the number one answer is batteries, which is a good thing because the project is about batteries. However, um, you can see other things like semiconductors, like we think is very obvious, or precious metals, or common metals, heavy metals. We purposely did not have the option of all of the above to see what people actually know about these materials. And there's a small portion of people that don't even know. And so, again, there's a lot of room for raising awareness. Moving on to people's perception about the convenience of different e-waste recycling methods. So first we talk about mail-in here. So for mail-in, as you can see, the very inconvenient or somewhat inconvenient um, is somewhat equal distribution, but across the board, you can see not a lot of people think this is convenient. When it comes to trade-in, which often um, takes place for phones, and then the convenience. So the percentage of somewhat convenient and very convenient now is about 66%. So it has gone up. Talking about drop-offs at transfer stations. So the somewhat convenient and very convenient now is at 81%. Drop-off at events are also considered convenient. So about 88% think that is somewhat convenient and very convenient. And then finally, pick up by recyclers, right? That's the ideal situation. So a lot of people think this is very convenient. However, it would require the participants to have a significant amount of e-waste to make it worth it for the recycler to pick it up. And so that's why, for the most part, this model is used by the companies more than household recycling. I just want to show here some aspect of our educational outreach event at local schools. So we conducted outreach at with different settings. This picture to the top left here, you can see that's an assembly, and I was walking around with a non-functional device that the local e-cyclists provide us, and so we can open up the back end of the back panel of the laptop and actually show the students what are the batteries, the hard drive, and so on. We also do like fair style, mini fair style. And so we set up different stations with different activities. So we teach kids about what are electronics, what's inside electronics. We also teach kids about batteries. What are batteries? How do they work? Include the energy stick activity and teach them about conductors and insulators. Then we also teach kids about how to sort um, waste materials. And so, like, we have three posters here representing mixed recycling, trash, and e-waste. And then we hand them out the cards. And then so the two teams compete, um, and we give them prizes based on the accuracy as well as the speed. And then toward the end, we have a call to action, and we do have control and experiment schools. So we provide the bins for them so that they can bring um, small e-waste items that fit into the backpacks to school. We also did fair style engagement in the community. So during the summer, there was a city fair that we got a booth, and then we set up different activities. Might be small to see, but it's a tabletop version of the e-waste sorting. Then we also have a bingo game for any age group can actually play um, to understand which electronic or e-waste contain data or battery or a combination of those. Our partner also were at the fair, and they ran the Jeopardy e-waste game, and this is a picture of the the winners. So every hour they have a Jeopardy game, and there are three winners. And they gave out refurbished laptops and tablets as prizes. Um, this picture here is a fishing game that a lot of kids love to play. The idea is Hidden under each of the fish is a material, actually critical material. And we ask the kid to fish out the three critical materials contained in a device. And so, yeah, that's some of the activities we've been doing. So for the last fiscal year, we visited 10 schools. Most of them are elementary schools, and there are some high schools as well. We taught 1,800 students about batteries, electronics, and the benefits of e-waste recycling. And we collected 540 pounds of e-waste. This is not a lot because we do have a goal of about a quarter of e-waste per student, which is about the weight of a cell phone that each student can bring in. So for this school year, we change in the incentive structure and see if that will help increase the collection amount. So far, we've used the raffle tickets. So depending on what students bring in, and so we have the rule like what item will have how many tickets, and then um, toward the end of the collection period, we will pull out the three winners, and the local e-cyclers will provide them with refurbished laptops or tablets or Chromebook, of course, with parents' consent. So just an overview of what we collected last school year, and we organized three school contests. Um, and so more than half are devices without data, and then loose batteries about 19%, and then the rest are devices with data, and most of the time they will also include batteries. In addition to conducting outreach and research, we try as much as possible to develop resources that can help spread out the practice of e-waste collection events. And so we have published a handbook related to best practices for organizing both indoor and outdoor e-waste collection events. We have also developed various videos to talk about the benefits of recycling e-waste, how to prepare e-waste for recycling, as well as the videos accompanied the handbook on how to organize an indoor and outdoor event. Here, just some of the educational examples. One is a coloring page that we developed as a handout. We also have the nice stickers for the kids. After we conducted the outreach at school, and to the right is the crossword puzzle about recycling in general, e-waste recycling, and critical materials. So for the next steps, we will develop another handbook on how to conducting e-waste outreach to various audience from elementary school to middle school to high school, as well as the community. So we're in the final draft right now, and we'll try to publish that soon. We will also work on our paper to compare the indoor and outdoor events um, for Idaho. And then we will also consider the first year of events as the baseline, and we will improve the communication methods and see that as an experiment and see if there's any improvement from changing the communication methods. And we continue to enhance school activities like changing incentives for e-waste collection. Um, so just want to wrap this up here. Collection events are actually successful in unregulated states, and this is very promising, and we're really happy to see that it works in a state like Idaho. And as I mentioned earlier, there are 25 states without e-waste collection, and so it gives hopes that we can actually collect more e-waste and reuse the materials. Um, Along with that, of course, awareness raising continues to be an important thing to help increase collection. So the aspects that we will continue to educate the public and the students on are critical material components, the importance of recycling, and especially how to recycle. And with that, I'd like to end my presentations here. If you have any questions or need to connect with the resources that we've developed for this project, feel free to reach out to me at ruby.nguyen@inl.gov. And with that, I'm happy to take any questions.
Awesome job, Ruby. Thank you so much for sharing your presentation. You've inspired me to take that trash bag full of e-waste in our garage and actually do something with it. So thank you for this conversation. We do actually have one question in the chat. And do you mind taking it? Would you like me to read it, or are you happy taking it from here?
Yeah, I can take it. So CD
Awesome.
asked if are there any plans to further analyze the survey using statistical methods? The answer is yes. As I mentioned, the data I presented here, just some of the raw data, but we will compare the indoor outdoor, so it could be t-test analysis. Um, Also, we compare the outdoor in Idaho and the outdoor in New York, because in New York they don't do indoor events. And we will also compare how is our recycling population different from the census data, just to have a better understanding of what is unique about the recycling populations and what can be done to improve recycling. Thanks for your question, CD.
I had a question, Ruby, about you mentioned that there's such variation between your regulated states and your unregulated states, and there's so many states who don't have programs right now. Do you see value in having more of a federal approach to e-waste recycling, or do you still see value having more stateside?
um, that's a good question, Celeste. I think the e-waste industry is continues to evolve, and it would be nice to have a federal approach, right? As you can see, why the recycling rate in Europe is so high is because everything is highly regulated. Um, and but the U.S. is a different setting, and so yeah, right now we're not taking a federal approach, and so it depends on each state, right? The legislators meet up, and if there's a case to say, okay, now we need to regulate e-waste, then it will become into law. Um, but yeah, but I think that's half of the battle. Why e-waste recycling is much more challenging in the U.S. Adding to the fact that we also have a lot of rural area and we have a lot of land, and so um, and if people have emotional attachment to a lot of devices that they own, it makes the situation much harder. In fact, um, when we um, run our campaigns, the message we use is not about doing the good things for the environment, right? We either say um, recycling e-waste, keep Idaho beautiful, or declutter your home by recycling these devices. And so, that's another aspect of messaging. Like as I mentioned earlier in the research landscape, right? There are various theories on how the intention, beliefs, and motives influence the behavior, but in different setting, you have to change the messaging to get the desired outcome.
Thank you. That's a great response. I had one more question, and others feel free to drop some into the Q&A box at any point. You showed a pie graph of the different e-waste that you collected at these events or at your event, and you mentioned that the largest chunk was the e-waste without batteries. Can you give some examples of what that would look like in a home?
Yeah. So e-waste without batteries include, for example, the older style or version of the vacuum cleaner, right? So you plug it in, um, or the Keurig coffee machine, the toaster, rice cooker, instant pot, right? A lot of the household appliances fall into that category.
Makes sense. Some of those larger items that might be more challenging to get rid of too. It's awesome. All right, Ruby, I'll have you advance to the next slide. If we have any other questions, please, others, feel free to add those into the chat. But thank you so much, Ruby, for your presentation today. A recording of this presentation will be available in about a week's time at aimslab.gov/CMI and on our YouTube channel, Critical Materials Innovation Hub. Please join us in early December on the 9th as we welcome Kevin Kuhn from DOE's NETL, who will present on the EDX, the Energy Data Exchange Run. As always, if you have suggestions for future webinars, please feel free to add those in the exit survey or email us at cmi@mines.edu. Well, thank you again so much, Ruby, for your time and for those of us joining, and we hope to see you guys in the next one. Thank you.
Yeah, thanks everyone.